something on shear force and bending moment. Remember, from the previous class, we defined shear force as the internal force that tries to slide a body. Then the bending moment is the bending effect that is felt on a beam. Basically, we're looking at a beam, right? So the shear force is the force that tries to slide the beam, that tries to make sure that tries to push the beam to either the left or the right. So then we said bending moment is the force that tries to bend the beam. Remember, we said that it's an effect of stress on a body. So the effect of stress on the body can cause tensile or compression. It can either be tensile or compressive. So when it is tensile, it tries to elongate the body. And when it is compressive, it tries to bend the body. So it's going to reduce the length of the body. Okay, we have to draw the shear force and bending moment diagram for the simply supported beam loaded as shown below. So we have 2 kilonewton here, we have 4 kilonewton, and then 2 kilonewton acting at several points on the beam. They're acting at several points on the beam. Then we have reaction forces acting at these other ends, holding the beam upward, right? It's acting, these two forces are acting upward, while these other forces are acting downward. Okay, so remember we said that these are vertical forces. So because they are vertical forces, sum of all vertical forces is equal to what? 0. What do we mean by saying that sum of all vertical forces is equal to 0? It means that the sum of upward forces is equal to the sum of what? Downward forces. That's basically what it means. So we're going to take all the upward forces. The upward forces include what? Reaction at A and then reaction at what? B. So we have reaction at A plus reaction at what? B is equal to, so sum of upward forces is equal to what? The downward forces. So the downward forces include what? 2 kilonewton, 2 plus, we also have 4 kilonewton plus 4 plus, we also have 2 kilonewton, we have 2 as well. So that will be what? 8 kilonewton. Okay, so that is basically the formula we have. That means RA plus RB is equal to 8. So that's very important. So now, we want to look at moments. I will say moments. When we talk about moments, moment is the turning effect on a body, turning effect at a point. So, if I look at the point A, turning effect is what is going to rotate this guy in the clockwise direction. That's the moment about what? Point A. So if I take the moment about point A, that means I'm going to start from A to actually take the moments. Take note that moments is equal to force times distance. Force times distance. So if that is the value for moments, so if I'm going to start from this particular angle, now take note that upward forces will be positive, while downward forces will be what? Negative. Upward forces will be positive and downward forces will be what? Negative. Okay, so if I'm looking at the upward force as being positive, I have RB. So RB times the distance. The distance covered is going to be 1 plus 1, 2, 3, and 4. So we have 4. RB times what? 4. RB is the reaction at B, and the reaction at B is a load. So it's either a force, the upward force holding that beam. So RB times what? 4. So we have a downward force here. So this downward force is 2 kilonewton. Remember we said that the downward forces will be what? Negative. So we have minus 2. Then the distance covered by that load is 1 plus 1, 2 plus 1, 3 times 3. Minus again, because of this other load is a point load. So the point load is 4 kilonewton. So it's acting at this point, and then we have the distance covered will be 1 and 2. So we have 4 times 2. Minus again is another point load. So we have 2 kilonewton. So 2 times 1 minus 2 times 1. So we said it's equal to what? Is equal to 0. So moment about a point is equal to what? 0. Same thing we said as what? Summation of all vertical forces equal to 0. Okay. So what are we going to have here now? We have 4 ROB minus 6 minus 8 minus 2 equal to what? 0. So we have that 4 ROB is equal to, so it means all these guys will go into this other side. So minus 6 minus 8 will give you minus 14. Minus 14 minus 2 will give you minus 16. Okay, so minus 16 go over to this side, it becomes what? 16. So divide here by 4, divide here also by 4. So we have RB is equal to 4 kilonewton. So if RB is 4 kilonewton, what will RB be? So you already have that RB plus RB is equal to 8. So it means that if RA is what I'm looking for, plus RB, I got it as 4, is equal to 8. Then RA will be equal to 8 minus 4, which is 4 kilonewton. So RA is 4 kilonewton, and then RB is what? 4 kilonewton. Alright, so with this information, I can now find the shear force. Okay. Can find the shear force. Okay, so what will be the shear force? So I'm still going to look from this particular point. So I have taking the moment, right? So I have ROB, the shear force at point B will be the same thing as what? Reaction at point B. So shear force at point B is equal to reaction at point what? B. So which is equal to reaction at point B, we said is 4 kilonewton. So shear force at point B is the same thing as the reaction at point B. Okay. Next thing is shear force at point E. Shear force at point E will be equal to, so we have shear force at point B, at point E will be this minus this. We have 4 minus 2, and that will give us 2 kilonewton. So basically, when we are looking for the shear force, we are reducing the forces till we get to this point. Okay, so we have shear force at point D to be equal to, we have 4 minus 2 minus 4. So 4 minus 4 is 0, then we have minus 2 kilonewton. Okay, then shear force at point C will be equal to, shear force at point C will be 4 minus 2 minus 4 minus 2. So we said that minus 2 minus 2 is minus 4. So minus 4 minus 4 is minus 8. The 4 minus 8 is minus 4 kilonewton. Alright, so the next thing is shear force at point A. Shear force at point A. So remember, we are subtracting basically because we said downward forces is what? Negative. So all these forces we are subtracting, they are what? Downward forces, right? this is an upward force. That's why we see maintained it at what? 4. Okay. So shear force at point A will now be 4 minus 2 minus 4 minus 2. Then here now will be plus 4. Plus 4. So here 4 plus 4 is 8. So minus 2 minus 2 is minus 4. Minus 4 minus 4 is minus 8. And then 8 minus 8 will give us what? 0. 0 kilonewton. Alright. So that is basically how to find the shear force. Now the next thing is finding the bending moment. Okay, so bending moment. Remember we said that moment has to do with force times what? Distance. So bending moment at both ends is equal to 0. Bending moment at both ends, bending moment at A is equal to 0, and bending moment at B is equal to 0. Okay, so now let's look at bending moment at point E. Bending moment at point E will be equal to, so we have the force acting here is 4, right? So you have 4 times the distance covered is 1. So 4 times 1, and that will give us 4 kilonewton meter. Remember, we said moment is what? Force. Force is in Newton, and then distance is in meters. So we have 4 kilonewton meters. So bending moment at point D, bending moment at point D will be equal to 4 times 1. Sorry, 4 times distance covered now is what? 2, right? 4 times 2 minus 2 times 1. So the effect of this force acts at 2 meters. The effect of this force acts at 1 meter. So minus 2 times 1. So this is 4 times 2 is 8. 8 minus 2, that will be 6 kilonewton meter. So bending moment at point C. Bending moment at point C will be 4 times. So yes, 1, 2, 3. 4 times 3 minus 4 times 3 minus 2 times 2 minus 4 times 1. 4 times 1. So that would be 4 times 3 is 12. 12 minus 8. 2 times 2 is 4. 12 minus 4 is 8. 8 minus 4 is 4 kilonewton meter. So we said that the bending moment at point A is equal to 0. So that is basically what it is. So you can confirm that that's the answer by basically doing one or two things. Putting it together, you get it. Okay, let's draw the diagram. So I want to draw the diagram for the shear force. And then we said okay, so this is our straight line, and then we have this point at the starting point, which is 0. So here is 0 kilonewton. So the shear force at B is 4. So I'll look for a point and call it 4. This is 4 kilonewton. So there's no load here. So what I'll do, I'll draw a straight line. Straight line. Okay. So shear force at E is 2 kilonewton. And if you come down at the point E to come down towards 2 kilonewton. Now, shear force at D is minus 2 kilonewton. There's no load here, so I'm supposed to have just a straight line. So this 4 minus 2 is 2 kilonewton. Then minus 4 gives us minus 2 kilonewton. So the shear force at that point is minus 2. So I'll move downward to this point. I'll call this point minus 2 kilonewton. So shear force at C will be minus 4 kilonewton. So I still maintain that minus 2 kilonewton. And then at this point, I'll come down to what? Minus 4. So here will be minus 4 kilonewton. Alright, so the shear force at A is 0. So I'll maintain this minus 4 kilonewton up to this point and then go back towards 0. 0 kilonewton. Okay, so that's basically the diagram for the word shear force. So I can shape this part. This part negative, and this part is positive. Okay. So the next thing is to draw that's the shear force diagram. The next thing to draw is the what? Bending moment. How do I draw the bending moment diagram? So I'll draw this, and then I'm going to have there's 0, here's 0, and it's up, it's positive, downward is what? Negative. Okay. So what do I do? I'm going to have bending moment at A is 0. So that is this point. And then bending moment at E is 4. So every straight line, I'll use that as an inclined line. Every straight line will be an inclined line on the bending moment diagram. So that will be an inclined line. Okay. So here is 4 kilonewton. So the next thing we have is 6 kilonewton. So still an inclined line, 6 kilonewton. So I will increase it a bit. 6 kilonewton. And then bending moment at C is 4 kilonewton. So it went back to 4 kilonewton. And then at point A is 0. So it went down to 0. Okay, so that's basically the diagram for the shear force and shape it. So this part is what? Positive. So this bending moment diagram and this the shear force diagram. Alright, thank you very much for being a part of the class. You can like, share, and subscribe for more. Thank you.